Good afternoon, everybody. Welcome to ERS-152, Earth's Changing Climate, particularly for those of us in here who are guests. Uh, Today I'd like to, today I'm very excited to introduce you to a person whom I consider to be one of the great science writers of our time. Uh, Graciously agreeing to visit us today and to share his thoughts on his recent uh, endeavor to see what can be done to solve global warming. Justin Gillis is here to speak with us for a short time and then to engage in a discussion. Justin he's an author. He's been working on a book about the energy transition for the past several years, as well as contributing articles to the New York Times recently. He spent a decade as a reporter for the New York Times, covering environmental science with a special focus on climate change. Many of his contributions were front page news, and he now continues to contribute pieces to the newspaper. Justin worked for the Miami Herald and the Washington Post, and he's been a Knight Science Journalism Fellow at MIT and a visiting scholar at the University of Oxford. And he's from Georgia. And so I should say that this photograph, many of you have seen before, the photograph that's being shared on the screen. We looked at that the second week of class when, at the height of the fire season in California. It was Mr. Gillis that was kind enough to share this photograph with us. So I put it up again today. Perhaps he can expound upon what's in that photograph. But in any case, without further ado, I'd like to let Justin take it away and talk to us about what can be done to solve global warming. So I'll stop sharing and I'll let you take it over, Justin.
Okay. Hi, guys. Thank you for having me. I'm really grateful, and especially grateful to Aaron, who I hope you know is one of the superstar climatological researchers of our time and paleoclimate researchers. I met Aaron under the aegis of the great, very famous Wally Broecker. He was down at Columbia as a student of Wally's, or really a researcher in Wally's shop down there. And I just have tremendous admiration.
Oh, yeah.
Sorry, Justin, my apologies. Sorry to interrupt. You've been muted. Can you unmute yourself, please?
Oh my God, this is painful.
Sorry about that. Continue.
Okay, how's that?
You got it. Yeah.
Now? Okay. Did a word of that come through, or probably not?
Yeah, most of it. Sorry about that, Justin.
Okay, was it was just muted for a couple of seconds, or
a couple of seconds?
Okay, all right. Sorry about that. I don't know if I did anything wrong.
No, I think I did it wrong.
Yeah. Okay, no problem.
Carry on.
So yeah, I was just saying I have sort of tremendous admiration for Aaron's research, and I remember the Genghis Khan stuff in particular sort of blowing my mind. You know, that there's this link between human society and the climate system, and I think it's a good little. It's a lesson for us that, you know, we don't rule this planet. We are sort of ruled by it. And it's very hard to get that through the heads of a lot of people. Let me just describe what I'm working on very briefly. Then I'm going to show you a few slides. And then for the bulk of this session, I'll sort of describe how I think we need to get out of this, you know, really deep hole that we're in. And then we're going to spend at least half the class time on your Q&A. So be thinking of, as I go through, I would urge you, I'm going to race through it really quickly because this is a very big, as you all know, hairy, complex problem. So if you hear something you'd really like to know more about, jot it down and we'll circle back and talk about that in the Q&A. So I'm working on a book with a co-author, and the title of the book, Simon & Schuster is going to publish it, we hope sometime in 2021. The title of the book is likely to be The Big Fix, and it's a book about how we get out of this problem. How do we solve climate change? Is there a way out? That's what we're trying to imagine is how do we get out of it, and what's the what's the politics that will get us out of this problem? I want to show you some slides now, and let me see. I'm a bit of a novice here at this. So I'm going to try to share this screen. Is everybody seeing that screen? Aaron, give me a nod if you're seeing it.
Got it.
Okay. That is exactly what it looks like. That's an octopus on the floor of a parking garage. This picture, it was a few years ago now, but this picture sort of went viral on the internet without any real commentary. And I think the reason for that is it's just sort of obvious that something is wrong here, isn't it? Octopi do not live on the floors of parking garages. And so people saw this and said, you know, something is not right, and sort of passed it around. Of course, the story here, this is down in Miami Beach. This is the ground floor of a parking garage in Miami Beach. And this happened during one of these episodic flooding events, tidal flooding events that are now becoming very common in Miami Beach. You've probably all seen pictures certain times a year. The ocean in general is now so high, so close to the brim, that, you know, people wind up sort of walking around Miami Beach in salt water, driving through salt water. They're spending billions of dollars to sort of, $500 million was the most recent figure to try to do something about this. So the octopus, you know, floated in with the tide, basically. And I think that said to everybody, something's going on here. This, to me, is a more dramatic example that you're looking at here. This is Highway 80, which is the only road to Tybee Island, Georgia, which is a community sort of near Savannah on a coastal barrier island there. I grew up in Georgia, and we used to go to Tybee Island as kids. This road obviously needs rebuilding. It's now too low in relation to the level of the ocean, but they haven't been able to get the money to rebuild it. Which again is sort of a symbol of the problems we're going to face, I think. This is now happening. What you see there is now happening multiple times per year, sometimes to the point that they have to close the road. But these people are trying to get home from work at night to their places on Tybee Island. And so if it's only a couple of feet of water, they've gotten to the point where they'll just leave the road open and hope that nobody sort of floats away. So that's kind of where we are with the coastal flooding stuff. The reason these things are happening, of course, you're all well aware by now, is sea level rise has, it's been proceeding more or less in lockstep with the Industrial Revolution and the emissions of heat trapping gases into the air. In fact, you can think of climate change or global warming as primarily the warming of the ocean. We're worried about all these effects it's going to have on land, but something like, Aaron, correct me, 90% of the heat is going into the ocean. When you heat up water, it expands, basic physical principle. And so here at the tail end, you can see the sort of little red bit. That's where we've been measuring with satellites. So we have these highly precise measurements. The earlier measurements are from these things called tide gauges, but you can sort of see we're in a relentless, slow but relentless trend of a rising ocean. We're worried about other things too from the climate crisis. We're worried about extinction risk. Now, human civilization has already caused a huge wave of extinctions. We're probably in the early stages of the sixth mass extinction crisis in the history of the planet. This one, the first one being precipitated by humans, but we think that's what's happening. This is an endangered critter in, I believe, Costa Rica. But there are just thousands of examples of many thousands of examples of creatures that, may be wiped off the map by continued climate change. I heard a beep there. Was somebody trying to say something, or Aaron, did you hear anything? Okay. Sorry about that. This might be our biggest single concern, is the threat to the food supply, to human agriculture, to what we eat. This blip at the end, these big jumps at the end of this chart here, this is a set of events that Aaron and I both lived through, where we had we had climate problems, extreme weather events, messed with the harvest in a bunch of different countries at once. This happened in approximately 2008 and then again in 2011, as you can see on the chart here. And so we had these huge run-ups in global food prices. You know, in rich countries, it wasn't felt so keenly, but in poor countries, 60-70% of people's entire budgets go to food. And so there were dramatic social consequences from this set of events. Here's I'm showing you in the darker tan here are countries where food riots broke out around the world. Governments collapsed. In the case of Haiti, the government collapsed because of these food riots. Here's a group of indigenous people in Mexico, you know, complaining about not being able to afford food. So if that event in particular, the food riots, more than anything else in my lifetime, sort of caused something to snap in my head, and I could begin to see how we get sort of a real social destabilization here. In other words, what happens if food winds up becoming scarce from year to year as a result of future climate change? It's a pretty scary situation. We could wind up with, you know, millions, tens of millions of refugees. We're already beginning to see a global refugee crisis that has already had pretty dramatic effects on the politics of a whole bunch of countries, including this one. So I'm not finding it difficult now, having seen a few of these things unfold, to see how society gets into real trouble, and we have sort of a massive destabilization. So you all, you know, I'm reviewing just the basics here. You all sort of know this by now. During, you know, we can go back close to 1 million years, about 800,000 years, and look at the level of carbon dioxide in the atmosphere, which is the main thermometer controlling the temperature of the planet. And you see here on this chart that between the low points are the ice ages, the high points are between the ice ages. I'm sure Aaron has explained CO2 plays this kind of amplifying role that helps us get out of the ice ages because we get a flux of it coming out of the ocean. And then you see where we are now with the current spike in CO2 levels, certainly faster than any spike in the history of the planet, we think. This is the point, if any of you have seen Al Gore's An Inconvenient Truth, which I very much recommend watching if you haven't seen it. This is the point where he has to sort of get in the cherry picker and sort of go up to the ceiling of the auditorium to sort of explain what's happening. Here's the consequence of that spike. This is the global temperature record, which I'm sure you've probably seen before. These numbers sort of look small unless you begin to understand that how much energy it takes to heat up an entire planet. Jim Hansen, the famous climate scientist, made the calculation that the heat we are putting into the planetary system is equivalent to 400,000 Hiroshima atomic bombs, the heat energy of 400,000 Hiroshima atomic bombs going off across the face of the planet every day. So we're putting a huge, huge amount of heat into the system, and that's changing everything, really. So for a long time now, we've been talking as a world, as a planet, about what do we do. We've been formally negotiating that question since the early 1990s. We've tried various things, including a treaty that you might have heard of called the Kyoto Protocol that attempted to sort of force countries to comply with legally binding targets and timetables. None of that worked. The United States refused to join Kyoto because it was legally binding. And so far we failed. I mean, we've had nothing but sort of increase in the CO2 level in the atmosphere. Finally, 5 years ago, in 2015, late 2015, what happened is, as a result of all that failure, we decided to change our approach, basically. And instead of attempting legally binding targets and timetables, we went to a voluntary system. Now, that sounds like you're going backward, but it had this sort of magical effect, actually. When we made the targets and made participation voluntary, suddenly all sorts of people, all sorts of countries showed up with higher ambition. We somehow unlocked ambition in the act of making the thing voluntary. So the result was this sort of landmark climate deal. You can see over on the right there under the phrase news analysis, I've got a little toehold on this front page, kind of explaining what just happened. It was very dramatic. The United States was a full participant in this. Barack Obama's administration kind of led the negotiations, especially with China. The Arc de Triomphe was lit up that's the Tour Eiffel was lit up in green that night, and everybody was really happy. And so then, and by the way, the commitments that the countries made were not adequate to meet our global goals. I'll talk about those goals in a little while. But they were much more ambitious than anything we'd ever made before. And what the treaty actually did, the structure of it, was to say, in fact, if you ask the question, what does this treaty require? The answer is legally almost nothing. Nevertheless, what it does require is that you got to show up every 5 years, and you country X have made a voluntary commitment to lower your global warming emissions. So come back every 5 years and tell us what's happened. Show us your homework. That's basically what this treaty requires. Show us your homework. And then while showing us your homework, you're going to make a new pledge. And we're going to go in these kind of 5-year increments. It's called the ratchet mechanism. And the basic idea is we're trying to ramp up countries' commitments over time to cutting their emissions. So everybody thought we were on a good track. 2020 was supposed to be the year of the ratchet, the year that we, that everybody ramped up and we got these bold new commitments. And then lo and behold, this guy came along. So there he is holding his Bible upside down. Donald Trump, as you all probably know, pulled the United States out of the Paris Climate Accord when he took office in early 2017. He started trying to torpedo every regulation and every rule we have at a national level that attempts to tackle climate change. Many of those rollbacks have been put on hold by the courts, fortunately. So now we've got Joe Biden going into office in January, we think, and strangely, these international treaties, it takes years to get out of them. So Trump couldn't actually get us out until November the 4th, just coincidentally the day after the election. So we only just came out of the Paris Climate Treaty. And then the 2020 ratchet was suspended because of the pandemic. So that's now going to happen in Glasgow in Scotland in 2021. By that time, we will be back in. They let you get in really easily, but it's hard to get out. So Biden, as soon as he takes office, is going to take us back into Paris. And we don't know yet what kind of commitment he's going to make regarding future emissions in the United States, but you can assume it will be ambitious. The Trump administration, of course, if they were still in office, would have made no commitment at all. So what did countries commit to and where do we need to go? This is a little chart. This is probably the most difficult slide I've got for you, and don't try too hard to figure it out. I can send this to Aaron if anybody wants a copy, but on the black line, you're seeing our historical emissions. I forget what the start year is, but that's emissions going to the sky, of course. The green downline, dotted downline, is where we need to be to meet the most ambitious target that was ratified in the Paris commitment, and that is to limit global warming to 1.5 degrees centigrade. Now, probably a lot of you know we're already just beyond 1 degree. This is, the baseline is, pre-industrial, before the Industrial Revolution. So, the less ambitious Paris target is 2 degrees C. We're already more than halfway there, or just about halfway there. And we'll be at 2 degrees in maybe another 50 years. We'll be at 1.5 in something like, somewhere between 20 and 30 years on current trajectory. I might be slightly off there, Aaron. I'm sure you can correct me. So you can sort of see under our current set of policies, that's the blue band, that we're nowhere close. If you take the pledges that countries have made so far under the Paris, the original set of Paris targets, that's the yellow band, and that shows you that we're probably not going to meet 2 degrees C under those pledges and targets, but we're sort of somewhere in the ballpark. If we're going to meet 1.5 C, we need a huge ratchet up in ambitions. Lo and behold, the news is starting to leak about what ambitions countries are going to offer in the 2021 ratchet that's coming up. And they're pretty bold. The Chinese have just said that they are going to try to get to net zero emissions, and we'll talk about what that means in a bit, by 2060, which is probably consistent with a 1.5 degree pathway, certainly consistent with a 2 degree pathway. Other countries have already announced, smaller countries have already announced net zero commitments by 2050. The United States certainly has not under Trump, but I suspect that's where Biden is politically going to feel forced to go, because, the United States doesn't want to come back in sort of looking like the goat at the garden party here. So that's kind of where we are on the global commitments. Now, if we're going to solve this, and pardon me, I'm talking so much, I have to take a drink of water here. If we're going to solve this, we need to break this problem into its sort of component parts. And we need to ask, where are the tons? Where are the emissions? The size of the sort of big black bubbles on this chart gives you a sense of the relative size of emissions from each country. It was about, I think, 15 years ago that China, with their rapid emissions growth, surpassed the United States. So I'll give you the more exact numbers in a minute, but China is now maybe going on double the emissions of the United States. You'll see we're still pretty big. We're the second largest emitter in the world. Throw in India, Russia, and if you throw the European countries together, the 28 countries of the European Union, they would have a pretty big bubble too. So just those 5, world regions, you've got the bulk of the problem. Everybody else is sort of an also-ran. You'll see Brazil is fairly big, and that has more to do with tropical deforestation than it does with industrial emissions. In most of these countries, it's industrial emissions that are the big problem. And we can see a more specific breakdown here. See, China is at 28%. The United States is at about 15%. All those yellow slices are various European countries. So you see that's a pretty big slice. So we're really talking here, even counting Europe, about, maybe a 20 or 25 country problem. If we can get those 25 countries together, we'd be pulling along the rest of the world. And, so it's not like we have to get all 193 countries to agree to everything. What's been happening with the emissions trends in those countries? Let's sort of break that down. The black line above is sort of all others. And you can see, and so India has its own bar chart here, but this is a whole bunch of developing countries kind of all rolled together that are now developing pretty rapidly, the way China did a couple of decades ago. And so you've got a pretty robust emissions trend from those countries. So, the current developing countries, the current poorer countries may be the biggest emitters in the future in the way that China has been in our time. So see what's happening in China. They've somewhat flattened out, but still increasing. You'll see that India is far below China because they're far below China on their development timeline, but also increasing. Lo and behold, though, look at what's happened in the United States. Look at what's happened in the EU 28. Our emissions have actually fallen since about 2005. 2005 was the peak for the United States. The European Union peaked earlier. And this is a direct result of policy in the EU. In the United States, it's a little bit more serendipity. When natural gas, when fracking developed and natural gas got really cheap in more or less 2005, we had a massive switch from coal to gas. We went from coal being half our electricity to today, not much over 20%. And gas has jumped up to be about 40%. Gas emits about half the CO2 of coal when you burn it for power. So that's a big part of our decline. And then in the later years, we've started to kick in with significant contributions from renewables, which are now about 10% of American emissions. That's just solar panels and wind turbines. If you add in hydro, it's closer to 20% of our emissions. Add in nuclear, and we're about 40% clean. So our power system is about 60% dirty right now. So now we've got to tackle this problem at the national level. As I explained, we've gone and made pledges and said we're going to come back and show our homework, but now we got to go home and do the homework. So what is our homework exactly? Well, you kind of get the picture here. You can think of this as sort of slices. I think of it as a pie with, quarter pieces, basically. Transport is now the biggest source of emissions in the United States. That's all our cars, but it's also, more than people think. It's trucks and planes and things like that, ships even. Electricity is a little over a quarter. Industry is a little less than a quarter. So I think of them as these quarter size slices of the pie. Agriculture in the United States, not that big. Globally, it's a different story. Let me go back to that actually. I meant to, where is that chart? Here we are. Maybe I'm sorry, I must not have put that in here. So agriculture and land use globally is like a quarter of the problem. So that's a critical piece of the puzzle, and it's something we have to tackle. I'm not going to go into it a lot, but if you guys are interested in the food problem and land use and destruction of tropical forests, we can talk about that in the Q&A. So now for just a couple of minutes, I'm going to show you the Greenland ice sheet melting from the top here. And while I do that, I'm gonna sort of I'll switch back and be a talking head in a minute. But I just wanted you to see, like, this is real, folks. This giant thing is starting to melt. I think once we get a more robust melting going on, we're not going to easily stop it. And so we are up against the wall here. This is an urgent problem. It's a crisis, and we have not gotten very much done yet, is the honest truth. And so we have to get moving. So how are we going to do that? So in some sectors, we don't even really know how to do it yet. We don't technologically know how to displace high carbon industrial techniques with lower carbon. For example, the world makes a lot of cement. You walk on it, you drive on it, you look at it every single day. We make a lot of steel. All those things you're driving on and looking at probably have steel inside, kind of holding them up, steel girders. Those two industrial activities by themselves account for about 11% of global emissions. And if you want, we can come circle around and talk about why, but it's a very large number. And we do not know yet how to displace that. So that's just an example of, with some of this stuff, we just don't know what to do yet, although people are working on it. There is one area where we kind of know what to do. And so that's the reason that we know what to do with the electricity system or the fact that we know what to do with the electricity system, more or less, is the key to the strategy that we need to follow. And the strategy is, what people call it is electrify everything. And what this means is, as I showed you, we've already gone a good distance toward cleaning up the electrical grid. We've got the technology now to go much further, much faster. In the United States, we need to knock out that remaining 60% that's being produced, 60% of our power system that's being produced in a high carbon way. And so the near-term imperative, the most urgent thing that we need to do is to build renewable energy much faster than we have been. My co-author and I have actually run the calculations on this, and we need to take what we've been doing over the last 10 years, and I'm sure all of you have seen, wind turbines or solar panels going up. We need to go about 5 times faster over this next decade than we've been going over the past decade, in order to sort of meet a kind of a reasonable 2030 target that then puts us on a path to getting to net zero by 2050. So 10 years ago, there was huge resistance to that idea. And the reason there was huge resistance is, let me end this here. The reason there was huge resistance was that it looked like it was going to be really pushed at the current costs of wind and solar back then. It would have been ludicrously pricey. But some people understood that there was a way out of this box. And so now I want to introduce a new concept. In fact, I'm going to share a screen again and just give you guys a couple of more figures here. Let me pick the one I need to share, I believe. Which one is it? It's this one. Aha, yep. Oh, that's messy. You know what? I need to load it. So pardon me just one second while I do that. That's here. Okay, I'm sorry. I thought I had this figured out. How do I go back to full screen? That's not working. Aaron, I've lost my Zoom control panel here. Oh, here we go. I think I figured it out. Okay, can people see that? Yep. Can you see a chart?
Mm-hmm.
That's a yes. Okay.
Sure can.
Okay, here's a really, really important concept, folks, and you've got to lock this in your head, because nothing that you're hearing out there will sort of make sense unless you kind of understand this. And the concept I want to get across to you is called the learning curve. You've probably used that phrase yourself, and you might have used it you might have said something like, gee, I'm taking Russian, but it's a really steep learning curve. That usage is really sort of the exact opposite of what it actually means when people are talking about industrial development. And what it really means is the deep history of our technological civilization, of technological development, tells us that if we have a technology that's young and new and in its earliest stages, it's going to be really expensive. When we begin to scale it up, the costs begin to fall. this has actually happened within your lifetime, maybe without you being old enough to sort of pay much attention, but a lot of people will remember, some people may remember when flat screen TVs came out. They were fantastically expensive. $10,000 they wanted to sort of get a flat screen TV. Now, of course, you can walk into Best Buy and buy a really nice one for, $300 or $400. That's the learning curve at work. And over here in this screen, you see examples of a couple of technologies that are really, really important that have undergone this, what we call technological learning rate. And what the concept means is every time you double production or double the output, double the installed base of a new technology, you drive the cost down by a certain percentage. So here in the case of lithium ion batteries, that probably averages out to, I'm going to guess, I don't have an average on there, but that probably averages out to about 25%. This is basically the last decade during which we've decided to scale this technology up and really take it to scale. Here's solar. These are solar panels. This is a calculated learning rate for solar panels. And you can see, make sure to pay attention over on the left side. That's a log scale. So every time we're doubling output of solar panels, we're driving the price down. Bloomberg's calculation is 28.5%. So these are huge numbers if you start to think about it. And Aaron, you could, I don't know if you've talked about, log scales in class, but, maybe afterward you could sort of explain to people. I mean, we're at a log scale right now with the pandemic, right? You've all just directly experienced what happens when something grows at a logarithmic rate, at an exponential rate. So, what had to happen 10 years ago was we had to decide we're going to scale this stuff up. And that meant paying quote unquote high prices. But a bunch of people decided to do that. The Germans decided to do it. The Americans in a bunch of different states, not nationally, but in a bunch of different states decided to do it. And lo and behold, in a decade, we've sort of driven these technologies down to a price now where they're competitive. And we're right at the point where we can go really fast on displacing a lot of high carbon electricity with low carbon electricity. We probably do not have the technology we need to get all the way there to 100% clean grid, but we can certainly get to 70, 80% using the technology we have, and then we'll be figuring out the rest as we go. I mean, it's going to take another 20 years at least. So that's the strategy. And then what we mean by electrify everything is once we have that clean, or starting now, as we begin to have a cleaner and cleaner grid, a cleaner and cleaner backbone, we use that as the backbone. To clean up the rest of the economy. So a really obvious example is cars. You all know that electric cars are now on the market now. I mean, that was a distant science fiction dream when I was a kid, but now we have them. We don't yet have robust uptake in the market, but we do in spots. So if you look in California, about 10% of the car market now is electric cars. Norway, maybe they may be feeling guilty about their sort of oil production, is actually strangely pushing really hard on electric cars. 60% of the new car market in Norway is now electric cars. So cars last a long time, of course. So it's going to, even when we get to 50 or 100% of the market, it's going to be a long change out to get all the way electrified. But to give you an example, Gavin Newsom, the governor of California, just announced the other day that he's going to try to put policies in place that ban the sale of gasoline burning cars starting in 2035. So, and the Brits already had a 2035 target to do that. They just announced that they're going to move that to 2030. So you guys, the younger ones of you, are only going to be in your late 20s, or maybe early 30s, when in some parts of the world, it becomes illegal to buy a gasoline burning car. So, and of course, that all depends on the electrifying the grid and electrifying the backbone. I think I went a little longer than I thought I would. So I think I'll stop there with just a couple of more thoughts, and then we'll switch to Q&A. So sharpen your claws. There's a couple more sectors where we don't really know what to do. And the biggest and most important of those is industry. I kind of mentioned cement and steel already, but there's a whole bunch of other examples where we use fossil fuels to achieve really, really high heat, mostly by burning natural gas. And we don't know how to displace that with electrified technologies yet. People are working on it. There's work on cement going on. There's work on steel going on. There's actually a couple of steel plants going into the ground in Sweden, and I think one in Germany, where they're going to burn hydrogen. And we think we already use a bunch of hydrogen in industry. It's made from natural gas, and the process emits CO2. But we may be able to make a lot of hydrogen from hydrolysis, which means you use electricity, in this case, clean electricity from the cleaned up grid, and you split water basically into its components of hydrogen and oxygen, burn the hydrogen in industry. So this is a multi-step process here where we've got to do what we can with the technologies we have and keep working over these next 30 years on new tech that can displace the old stuff. And then once we have the new tech, we need to scale it up as rapidly as possible. That, in a nutshell, is how we get out of this box. And are we going to achieve it? I mean, if you look right now, you'd have to say we're not on track. I mean, you guys can just look around. You can look out the window probably and see that, there's no sense of urgency out there about getting going. But, with the new administration, with a rise in public consciousness about this issue, which I think we're in the middle of, this may be the decade when things change and we really get rolling on the issue. So with that, I think let's switch over and do the Q&A.
Sounds great. Thank you so much, Justin.
Sure.
That's very interesting. So let's open it up to questions now. You can either raise your hand in the participants section and speak, or put a question in the chat for Justin. What are your questions for Justin?
Hi, Aaron. I have a quick question.
Go for it.
So thank you, Justin, first of all, for coming and giving this talk today. It's been very informative.
Sure.
My question for you is, you've talked a lot today about kind of world governments being the big players in global climate, reducing the change we're making. Us as the general public, do you see us more as kind of along for the ride? Are there things we can do to also be big players in this change?
Yeah, that is a fantastic question. You're most certainly not along for the ride. And here's why. In order to make this decision to quote unquote overpay for things and get them to scale up, what does that require? It requires a political commitment. It requires governments being willing to sort of hold their noses and say, okay, we're gonna make you electricity companies overpay for a while, or we're gonna, sometimes it's carrots too. We're gonna offer you $5,000 a piece to, switch to an electric car. A bunch of states already do that, by the way. The federal government was doing that for a while. So we need a more urgent political demand. A lot of young people that I meet who are overwhelmed by this problem and not sure what role they can play in it sort of come to the conclusion, well, I'll just do what I can. And so, they recycle more, or they, change their diets and eat less meat or eat no meat, which we can talk about if you guys want to. Potentially important intervention there. I guess I'm here to say that's all good stuff to do, but the most important thing you can do is vote and use the power of your vote. I would have said that 10 years ago, and I would have been a little bit hopeless about it because we were not yet seeing, voting majorities that sort of cared very much about climate change. we just went through an election when, for the first time in American history, this issue played a big role. And you saw it in the Democratic primaries where, Biden was forced into a much more progressive position on climate change because he was getting, really hammered from the left. Now, I think that position is sincere. When he was in the Obama administration, they worked pretty hard on this issue. So the power of your, using your vote as essentially a climate vote, making clear to any politician you encounter, excuse me, that this is at the top of your list of priorities is an important thing to do. And then you probably have more power than you realize to influence people around you. So I've met kids who are really intensely into the climate fight, and the most interesting revelation that I got from a few of them was when they said, I talked to my grandmother about this issue and she didn't know I cared about it. And when I explained that I cared about it, it became a voting issue for her. So you have the ability to influence people around you. And, the pitch is pretty simple. I've got to live in this world we're creating. I'm a young person. You're older. You care about the fate of your children and grandchildren. Do something about it by voting the right way on this issue. Am I answering your question in terms of sort of what you can do?
Yes, thank you.
Yeah, sure.
That's great. We have several questions in the chat, so I'll start off with Savannah's. Why has climate change become such a politicized issue despite ample evidence and supporting research in regards to its existence?
This is another really good question, and I don't know that I really know. I can sort of tell you a little bit of history. I mean, it's really interesting. I sent you guys the piece about Dave Keeling, and if you read that piece, Keeling was a Republican, right? So like the guy who basically discovered this problem was a Republican. We went for many years when it was just discussed in these kind of technocratic terms. Nobody was really taking it very seriously or being asked to do anything. It's when we got to the point that that we had the beginnings of a political demand to do something that the issue started to become politicized. And I think, the American body politic is a sort of complicated beast. We're similar to Australia in having this fiercely anti-government faction that I think goes all the way back to kind of the frontier and sort of pioneer days and all that, and is kind of echoed down to our modern politics. So, when we started to discuss, basically heavy government intervention in the economy, it would have been less heavy then than it needs to be now, but heavy government intervention in the economy, two factions woke up. The sort of libertarian faction of the American right said, wait a minute, we don't want the government telling us what to do with our energy system. At the same time, the fossil fuel companies perceived this huge threat to their business model. A lot of you probably know early on, they were among the most important researchers, like documenting what was going to happen. But once it became real politically, the C-suite took over, the executive suite took over, and essentially started throwing up a lot of money to create doubt and obfuscation. And if the class wants to follow up on this, you ought to track down and show them the infamous Frank Luntz memo, which I can probably send you a link to. But it was a guy named Frank Luntz, who since changed his mind, by the way, while watching Los Angeles burn outside of his window. But back then, he was a Republican pollster type who counseled them essentially muck up the science, mess with people's understanding of the science, create a kind of scientific dissenter faction. And basically their idea was this is the easiest path to preventing action. All we need to do is create doubt in the public mind about this science, and the effect of that will be to sort of slow things down. And so that's exactly what happened. And so in the end, global warming got pulled into the American culture wars. I mean, it's now up there with sort of gay marriage and, issues like that as this sort of intensely right versus left faction and, right versus left fight. And only very recently have we begun to see a few Republicans kind of tiptoe, back over the line and say, hey, this problem is real and we need an answer to it. Younger Republicans, they poll, very pro-climate action. So there's a huge age divide within the party, which tells you how this is going to get solved in the long run, but we need to solve it in the short run somehow. Is that a good answer, or is that too long of an answer? Probably.
I just like to add a little comment to that my PhD was in large part funded by the National Oceanographic and Atmospheric Administration, and that was, especially in Maine, one of the big proponents and supporters of that was Susan Collins. So I just found it surprising that this has taken on such a political bent. But
I mean, it's really unfortunate. If you look at say Britain, for example, all of Europe, but Britain, for example, they have a robust cross-party consensus to tackle this problem. And American climate denial has kind of leaked over there and become a little bit of a factor, but it hasn't broken the consensus. And so Boris Johnson is a conservative, and he just came out with a huge new global warming package that, they're trying pretty hard, right? And it's just sad. It's, United States, Australia, a handful of places where the political right just won't commit. Breaking that is what we need your guys to help us do, and that's, that's converting more people into making this. I mean, it's especially important to convert Republicans because we need those politicians to start hearing from their constituents, their base voters, that they want this problem solved.
So we have some more good questions in the chat here. They keep rolling in. Let's see here. Well, this is a curious one, and I'll bounce around to people. So don't worry, I'll try not to miss your questions. But Justin asks, a main component of lithium-ion battery cathodes is cobalt and nickel. These elements are found in very small fractions of the Earth's crust. Also, a large proportion of cobalt is found in the DRC and mined by children while creating tailings, polluting local water supplies. Apart from the supply chain issues, are these elements available enough to sustain the ability for us to have EVs, or will we be forced to change our lifestyles and engage more in ride sharing and public transportation?
Who asked that question?
That was Justin.
I'm not seeing a Justin on here.
I'm right here.
Hi. Well, that's a fabulous question. You were up to the minute here on this stuff. It is a problem. In fact, there's sort of no free lunch here in terms of materials and the ecological impact of industrial civilization and sort of 7 billion, soon to be 9 or 10 billion people trying to live on a small planet. The cobalt thing is extremely worrisome. It is a dirty supply chain. People know that, and they're working on it. And one of the prime approaches is just to reduce the amount of cobalt that we need. So if you guys paid any attention to, Elon Musk has this thing every year that he calls Battery Day, where he talks about sort of future developments in batteries. And we're still on a very steep learning curve there. We're probably only a few years away from battery cars being actually cheaper than gasoline cars, which will be kind of a milestone when we get there. So, Musk's position is we're looking for a way not to use cobalt at all. Meanwhile, we're trying to reduce the amount of cobalt. So there's that approach. Lithium is earth abundant. I mean, there's no question there's enough lithium in the Earth's crust. It's a bit like uranium. If you really ran out, you could go and the price went way up. You could go extract it from the ocean. I mean, you could do that with uranium. There'd be an energy cost to extracting it. I have a really good friend out here who's found a better way to extract lithium out of bronze. So the United States may be about to go into the lithium extraction business. We mostly import it now. So the answer to your question is there are huge supply chain issues here, both on the front end and on the back end of disposing of all these things. We haven't quite reached the point yet where we're taking out a lot of solar panels, old solar panels. We've got to figure out how to recycle them. We've got to figure out how to make a closed kind of circular economy where we're not wasting this stuff, we're reusing it. It's interesting, one of Elon's top guys left a couple years ago to set up a company that's going to be focused completely on lithium battery recycling. So people are beginning to work on it, but if you want a career, like the back end of the renewable, supply chain is a wide open career move. And, the short answer is I think we can figure out how to do it in a much cleaner way than the fossil fuel economy ever was or ever could be. But we're not there yet. We need to figure it out.
That's great. All right. Well, I'll go to another question in the chat. Let's see here. Sam asks, are you familiar with any of Al Bartlett's work? How do you think the balance of economic reduction and growth and the transition to, what do you think of the balance between economic reduction and growth and the transition to green energy?
I'm not familiar with that author. Is this the sort of degrowth argument that we need to essentially cut consumption radically, or explain to me what the argument is a little bit more, Al, if you would.
Yeah. Sam, would you like to
Sam, I'm sorry,
comment?
Yeah, so it's more of a question of how we can't really grow our way out of the, position we're in. We can't really fix it all with technology. So there's a big argument that really the only way out is that we, reduce our growth, population and economic wise.
Yeah, so this is more or less called the degrowth argument. There's actually a couple of climate scientists. Aaron, you probably know Kevin Anderson, who's one of the people who's made a big case along these lines. I guess I don't really buy it as a. I can't see how it becomes a workable political program. So, if the idea is, let's cut our consumption in half, so that we're just putting less strain on the planet. That's just going to be a hard sell. I mean, what would it mean in the lives of the average American? You're going to have to, have a house, half as large as now. I mean, don't get me wrong. People should do this if they are willing. But you have to, when I think about degrowth and I try to imagine, how would we actually pull that off as a political program without eliciting such a backlash that it destroys all the goals, that it destroys the entire program? I can't reason my way out of that. I mean, I've thought a lot about it, but I just can't see how we get there. There's a lot of writing about degrowth and sort of pro and con, and Sam, if you want to follow up, I can sort of point you to some stuff to read. Personally, I just don't really buy it as an approach to this problem. I mean, just think about, we're going to have, at least 3 billion more people before food production before population peaks and begins to decline, which it will do, we think, middle of this century. But, food production, even if we waste less, and we do waste a lot, food production is going to have to go up, not down. There's no question about it. So, and you can cite other examples like that, where seeing human consumption decline is a very hard thing to imagine, unless you want to, invoke say a pandemic much worse than the one we're in now that sort of kills off half the population. But in terms of a voluntary program, I don't see how we get there. There's some things that people don't understand about this, though, that are critically important. For example, if I move you from a gasoline burning car to an electric car, I've just cut your energy use by probably half for the same miles without you noticing any effect at all on your lifestyle, other than the fact that, you got to charge it up rather than fill it up. And that takes a little longer. But that's a pretty small penalty for cutting your energy use in half. Now, people don't understand that because they don't understand the basic fact that when you put gasoline in a car, only about 20% of the energy in that gasoline is actually converted to, motive power at the wheels. 80% of it is wasted and goes out the tailpipe as heat, essentially. So it's a gasoline car, despite how fancy they've become, is an incredibly inefficient system. So when I think about cutting consumption, I think not about saying to people, you need to stop driving, or that is one approach. Like, this is a whole thing we could talk about, is sort of making our cities better, and mass transit and all that. But I think more about, if you're living in a suburb right now and driving a gasoline car, I can move you into a car that's going to affect your life not at all, but yet cut your fuel use by 50%. There's a bunch of stuff like that where we don't suffer, insulating our houses better. We don't suffer because we don't want our houses to be any hotter than they already are. But we're using less energy to sort of get there, right? So when I think of cutting consumption, that's what I think of, not some political program that's going to somehow persuade people to live completely different lives. I realize this becomes ideological and other people feel differently about it, but I guess that's my approach to the problem.
And there's actually a related question that builds on that from Peter saying, hello, Mr. Gillis, great talk. Thank you. Similar to Sam's question, do you think there is a way for countries to meet emissions goals without carbon capture? And will that be a necessary technological development?
Well, you guys are on the spot here today. It may be necessary. Some of the industrial stuff that I was talking about that we don't know how to do, people are looking for sort of alternative chemistries for cement, for example. But probably you guys know that most of the emissions from cement is not coming from energy use. That's only maybe about a third. Most of the emissions are coming from direct conversion of limestone into clinker. So you're driving off carbon when you do that, and that leaves the process as carbon dioxide. So alternative chemistries are a possibility. There's some early commercial products in the market already, but it may be that the only way, if that turns out to be too expensive or not practical, it might be the only way is to capture those emissions and bury them. It's possible that will be the case with steel as well, which has a large carbon footprint. It's entirely possible. In fact, I'm writing a column for the Times right now where we're going to propose a sort of a take back obligation on the carbon companies, force them, to capture an increasing percentage of their emissions over time. I think it would ultimately drive carbon off the market. But if you think CCS is going to be carbon capture and storage, meaning capture it and put it back in the ground, is going to be a viable option, then maybe we can crack the economics of that. Maybe we can get it onto the learning curve and make it cheap enough to use, right? With electricity, I'm not so convinced that we'll need it in the late stages of the electrical system decarbonization, because we've got some other options for the part of the power supply that needs to run 24 hours a day. But we may need it. That's possible. So I am in favor, we are in favor, and we're going to be in favor in our book of more government expenditure to experiment and company expenditure to experiment with carbon capture and storage and see if we can crack it.
Great. Well, there's another question here, and that I think I mentioned to you before. We have a few students in here who are studying communications and journalism, and so this is from someone who's studying media relations, Annika. This question is less about climate and more about media. You said it's especially important to convert Republicans to believing in climate change. How is this possible when Americans tend to go to news sources that will confirm their bias? New York Times, for example, is widely regarded as a left-leaning newspaper, so people who are more politically right may avoid it or doubt what it says. I'm studying journalism, so I'm wondering if we have to work on media relations and revitalizing people's trust in the news before we can educate anyone about anything.
It's so true, and you've put your finger on a giant problem here. Maybe the problem of our time in some ways is, people kind of no longer speak the same language, no longer share the same set of facts, and you can think of climate change as just a subset of that much larger problem. We don't speak the same language when it comes to guns. We don't. I mean, there's a whole long list of issues that you can go to, right? I don't have an answer to this kind of polarization of the news media and the silos. I've got some partial answers. This is probably the only thing I've ever agreed with Donald Trump about is we need to repeal Section 230 of the Communications Decency Act. That's the little 2-sentence provision that waived all legal liability for Facebook and Twitter and the right wing, even the far right. Well, these people that are fomenting violence, for example, political violence, are completely immune to anything that's, to the liability for anything that's said on their platform. We need to revoke that and treat them as publishers. If I publish something libelous in the New York Times, I get sued, the Times gets sued, and, we probably wind up paying millions of dollars, which is why we're very, very careful not to publish libelous things. And, very careful in general to try to stick to facts. So, we do have to, and, weirdly, there may be a sort of cross-party consensus on this. We haven't done it yet, but they're looking in Congress for ways to hold these companies more accountable. What would that mean in practice? I think, it might take some of the juice out. You might get to a world where you can't say just anything on Facebook. We certainly need to get to a world where Facebook knows who you are. They've verified your identity before they've allowed you to have an account, right? I mean, so I think there's some ways that we could, there are policies we could adopt as a nation, including just stricter enforcement of the antitrust laws on these on the social media companies to try to break down the silos. And then the whole other direction is the one I talked about earlier, where politically, I don't know, if any of you has Republicans in your close family or your parents or grandparents, raise your hand. So you're in touch with people that you can have a conversation, and they know you and they love you and they care about you, and you can have hopefully non-confrontational conversations about this issue. The place to start is a whole lot of people out there have begun to notice that there are changes in the weather, right? I mean, it's just become kind of undeniable, and people are being hit, individually by floods and, on the Gulf Coast, multiple hurricanes this year. And so we need to tap into what's happening in the real world and say to people, look, there's a chain of evidence here and a set of consequences. And we need you, even if you stay Republican on every other issue, we need you voting on climate, in the right way. So I don't know, not a perfect answer to a very complex set of issues, but it's a couple of ideas anyway.
Let's see here. A lot of great questions coming in. There's another question about carbon capture. Do you foresee an issue in the future with storing vast quantities of carbon underground if CCS is needed?
Who asked that?
Sorry, that's Skylar.
I asked that.
Okay. Another really good question. And the answer is yes. In fact, if we're going to need it, if we're going to need CCS at, massive industrial scale, that we will probably need it, in the late 2030s, early 2040s, sometime in that time frame. The reason we really need to get started and pushing harder on this now is exactly this problem. In fact, there was a good example of a project. Queensland in Australia 20 years ago went rushing off and said, "We're going to figure this out. We're going to prove." They have a huge amount of coal there, so we're going to prove that we can just put it back under the ground and everything will be fine. And so the politicians picked a spot and put up a bunch of money and said to a bunch of scientists, "Okay, go build this demonstration project to make it work." The scientists went out there. Of course, you can see this is happening in the wrong order, right? The scientists went out there, started drilling and said, "What's down here?" And they ultimately had to go back to the politicians and say, "I'm sorry, this is not a good place to put this. It's not a good reservoir under there. It won't hold the CO2 long term. The closest place that we could do this is 200 miles away. And by the way, that pipeline is going to cost you $5 billion or whatever it would have cost," right? So the characterizing the reservoirs is right now the urgent problem. Not all these, many parts of the world have layers down there, aquifers down there that would be good for storing, that will be effective for storing CO2. But we don't know where they are yet. We haven't really done that characterization. It's a little bit okay in the United States because this fabulous agency, the U.S. Geological Survey, has been working on this. But there are other countries, like the Chinese, have no clue what's under their ground. They don't even know where their gas fields are, much less where their carbon storage fields might be, right? So the picture around the world is we just don't have a clue yet. And this is the reason we need to push really hard right now, because we need to begin understanding the technical characteristics that'll be required if we're going to store really massive amounts of carbon underground.
Great. Well, we're nearing the official end of the class, but we can keep going if you like, and people can leave if they wish. But I wanted to get back to a question that Amy asked earlier on in the chat. She'd love to hear more about the consequences of animal agriculture on climate change, if you have any words to offer.
Yeah. Oh, so here's a big problem. Animal agriculture, and particularly beef, you probably all know, the most intensive of it's the most intensive of the common foods that we eat, climate intensive. It requires a large amount of land, requires a large amount of feed. It's driving deforestation, and it's not so much that they're growing the cattle in Brazil or Peru. They are some, but it's more that they're cutting down the tropical forest to grow soybeans to send to China so that China can produce. There are pig farms there with 1 million pigs, in one giant sort of confined animal feeding operation. So the overall contribution of land use and land conversion in the world is about 25%. And the biggest problem is in the tropics. So in other words, 25% of the emissions. The biggest problem is in the tropics. And we're a little bit stymied because it's kind of unclear how to affect that in the countries where climate has become a big issue. Now, the Brazilians have done a great job of cutting deforestation. Only very recently have the Indonesians gotten serious about it. The biggest problems have been in Brazil, Indonesia, increasingly now the Congo Basin in Africa. We're seeing a big deforestation problem. We're going to say in our book that, so this is one area where consumer action might be really important. In fact, to the extent we've made progress so far, it's come because consumers have put pressure on companies and said to them, we do not want you contributing to deforestation. You don't know that you buy a whole lot of stuff from Cargill, but you actually do. You know, when you go to the grocery store, you're buying products that were produced from commodities supplied by Cargill, which has been dubbed the worst company in the world. There's actually a report, the worst company in the world, that you can sort of look up and read about Cargill and the things they do. So saying, not eating meat or eating less meat, and particularly less beef, is a good step if you have the discipline to take that step. If you can't go vegetarian or vegan entirely, then switching from beef to a lighter meat is good. You can kind of think of it as beef gets 20 miles to the gallon, pigs get 40, and chickens get 80. And in fact, in the world, we're in the middle of a big switch toward chicken. Believe it or not, like beef is losing, chickens are winning. Governments have been really chicken, so to speak, about trying to affect this issue. I mean, when's the last time you saw, anything from the government saying you should switch what you eat, right? They're terrified to do anything. So what we think needs to happen ultimately is governments have got to get involved. And in fact, we want the Biden administration to do this as kind of a test case. We think they need to say to Peru, I'm sorry, if you don't cut your deforestation by this amount, then we're going to impose tariffs on any of your products coming into the United States. And, if you go X number of years without cutting it, then we're going to consider an embargo. In other words, we need the tools of the international trading system deployed on this problem to get countries to be more serious about cutting deforestation. Now, a lot of them have made big commitments in the negotiations. The climate negotiations. A lot of them made big commitments in Paris about how much they were going to cut, and they are not on track to meet those commitments mostly. Did that answer the question? Feel free to follow up if I'm missing your point.
Is it a yes, Amy? Yeah, it's okay. Great.
Okay.
That was great. Thank you so much. I appreciate it.
Sure. Yeah, and Aaron, if you want to put us in touch and she wants more, I can follow up with anybody who wants to read in more on some of these specific issues. I'm drowning in material right now, as you can probably tell.
Yeah.
So yeah.
Oh, that's great. Well, certainly if anyone would like me to seek more information, I can always pass the word on to Justin and we can exchange reading materials.
Yeah.
Justin, how are you doing? Do you want to keep going or?
I'm okay for as long as you guys want to go to maybe the top of the hour. So another 10 minutes, if that's, I know class is officially over, so anybody who wants to drop off can, I think, without penalty, right? But yeah, I can go a little longer if you guys want to.
Sure. Oh, okay. Since we have you captive, there's a question from Sydney who says, as a social work major, part of our code of ethics focuses on social justice. Part of this focus in our courses is to look at the issue of climate change and how it affects vulnerable populations of oppressed and marginalized groups of people, including indigenous peoples. Indigenous communities have been some of the best examples of how to care for our land while also caring for the individuals within the community. Are there any lessons we can learn from indigenous cultures in terms of care for the community that we can use to bridge the deep divide that we're feeling politically in America?
I think the answer is yes. And so this sort of ties back to the previous discussion in a way. A lot of the story of, let's say, agriculture in the tropics, of course, has been the dispossession of indigenous people who've been stripped of their land rights. A guy, actually, a Peruvian economist, I'm forgetting his name, actually won a Nobel Prize in economics for making the case that the lack of clear land tenure in a bunch of countries, many of them tropical countries, is one of the world's biggest problems, actually. You know, so if you don't have clear land tenure, you know, whoever's got, you know, the bigger guns can sort of come in and dispossess you, right? And that's happened over and over and over again. So I think we need a global program of trying to clear up these land tenure issues. We need to give a much bigger voice to indigenous people in how their lands are managed, certainly in the tropics. That's also true in the developed world, the industrial world. There's a really interesting story played out this summer. You guys saw the picture with the fires, you know, the orange sky in San Francisco. I mean, that was an incredible thing to live through. And, you know, so now out here in California, we're suddenly fervently talking about, you know, what do we do about the fires and the fire risk? And lo and behold, there's an active consultation going on right now with indigenous native communities who still have historical knowledge about the way the Indians managed the landscape before white colonization, white settlement. And, you know, people don't know this, but there were over huge amounts of territory, Native Americans were burning the landscape to sort of control the fire vegetation, you know, the buildup of vegetation and so forth. So there's now, like, you know, advice being sought, you know, from indigenous people about, you know, how do we do this and do it in a proper way, and when do we do it, and what weather do we need, and all this sort of thing. So, I mean, my short answer is yes to the question, the specific question. How to do that is probably very location specific and, you know, specific to the indigenous community that we're talking about. Poor people more generally, let me give you one more kind of little data point on this. If you draw a map of asthma cases, let's just say you take a map of Los Angeles and you overlay asthma cases, asthma attacks, you'll see, first of all, those asthma attacks are heavily people of color. You know, asthma is, you know, disproportionately affecting Black people. And when you place those cases on the map, you can see the freeways of Los Angeles on that map. I wish I had an example. I don't have it at hand, but what that's telling you is, and we know about this historical injustice, that's part of the high carbon economy, right? When we built the freeways that allowed all this suburbanization, you know, this very high carbon, you know, car-based economy to develop, we plowed through the poorest communities in town because they were the ones that had the least political power. This is a vast topic, right? The history of the American freeways and the way they, you know, wrecked the Black communities of the United States. But it's not just, people think of it as just a historical injustice. It's a continuing injustice. We're poisoning those Black kids right now with fumes from our automobiles, and they're getting asthma in disproportionate rates as a direct consequence. So, you know, even if we don't tear down the freeways, you know, electrification of cars is instituting justice in communities where we have ongoing injustice right now. A lot of people don't know that, but it's a very dramatic example, actually. So I don't know, have I answered this question sufficiently?
Does that answer your question, Sydney? Are you okay?
I feel like people are muting and stuff.
Yeah.
Plus, you all keep jumping around on the screen. It's hard to keep track of who I'm talking to.
Well, does anyone have a final question before we let Justin go finish his coffee and re-energize?
Yeah, I guess I have one. I think I put it in the chat. So I'm just wondering, we were sort of talking about it at the beginning, but like, what do you think is the place for like local, like grassroots movements in making like a larger change, you know, nationwide? Like I was part of that, a movement on my town, and we got stuff done there, but like, how could that be done throughout the rest of the country?
What did you get done?
We got a like a committee set up to tackle our impact on climate change and how to like deal with what's going to happen on Mount Desert Island. And so there's 10 members on it, and we have representatives from all the stakeholders, including the youth on the island. So we're quite happy with that.
Yeah, I love Bar Harbor, by the way. Boy, I'd love to be there right now. That's another really good question. You know, we're going to argue in our book. How do I say this delicately? We actually think the climate movement in the United States, first, you know, I'm thrilled that there is one, right? I spent a lot of my adult life saying, you know, when is the public, you know, demand going to come, right? And now it's here. Now we can get, you know, 300,000 people marching in the streets of New York, which happened in 2015. We're finally at a point where there is a movement. So that's a huge change. My co-author and I think that this movement has been a little blinkered or naive, I guess is the kindest way to say it, in its choice of targets. For instance, there's a huge focus on pipelines. Let's stop pipelines. And I'm kind of saying, if we cut the demand for fossil fuels, we're not going to have to worry about the pipelines, right? The pipelines are going to go away if we can eliminate demand. But you don't see, and I love Bill McKibben, but you don't see Bill putting a lot of energy or, you know, into how do we cut the demand, right? You know, the early political targets were picked, I think, for show, basically to kind of demonstrate that, you know, here we are on the case and you're not going to get away with this stuff anymore. But we need the argument in our book is we need a broader set of targets. And to give you an example, there's almost no work at all in terms of political activism going on relating to building codes. Yet, this is one of the biggest problems we have is getting towns to be, you know, we are still putting up crappy buildings in America. We are still putting up buildings that are going to be climate liabilities for the 50 or 100 years that they exist.
That was one of our big things, was trying to get those. It was so difficult.
Zoning right. So there's going to be specific advice in our book. And, you know, again, if you want to follow up with Aaron, I can point you to directions. But, you know, there's a bunch of things we need cities to do right now. We need them to ban new gas hookups in buildings. We need to electrify buildings just the way we're going to electrify cars, right? And there's a magic technology called a heat pump that allows you to do that. We've already got a trend now. About 60 towns in California within the last year have banned gas in new buildings. So they're requiring all electric buildings. That needs to become a trend throughout the United States. That can be done through building codes, which are updated every 3 years. So you've got a huge target right there, requiring tighter insulation in the buildings. There's all this stuff we can do. And I don't understand why this hasn't become a political target, because in a lot of ways it's easier than, you know, like cars, you kind of got to deal with it, you know, at least a state, maybe a national level. How buildings get built is very much decided locally, right? And so there's an opportunity there, and it can't be that hard. Like, you had a committee, you go down to City Hall, you probably get, you know, 30 or 40 citizens going down there 3 meetings in a row, and you've got it done, right? I mean, a little bit of political pressure, and these folks will fold usually, but, you know, we got to do that. The problem with it, of course, is we got to do that, you know, in, you know, 10,000 towns in America, right? We got to replicate it over and over and over again. We think that's the frontier of where a lot of work needs to be done right now, if that makes sense.
Yeah, our problem was we didn't, initially, we didn't have like the intellectual resources to like know exactly what to do. So like you just said with your book, like something like that would be revolutionary for a lot of the people on the town council.
One way we're framing, we're framing the book. We say in the book, you know, there are these secret levers in the economy that you don't really know about. And we need to know about them. And then we need to know how to pull them and pull them hard in the right direction. And, you know, one of those levers is building codes, right? That's a major lever. And But people don't understand it. They don't understand the 3-year cycle. They just don't understand the basics of how it works. So we're going to try to explain that to them.
Well, that's great, Justin. Thank you so much for taking the time to join us today. And I'll apologize. There are actually a lot of great questions that I probably missed by accident or that we didn't get to. But thank you so much for doing this. I hope we can do it again.
Sure. And thank you guys these were great questions. Every single one of them made me stop and think. So I look forward to seeing you guys out in the world and see what you can help us accomplish.
A new great generation.
Yeah.
All right. Well, that's it for the class, everybody. Thank you all for coming, and that'll conclude it. We got plenty of questions, Justin, so we went even 15 minutes over what we expected.